It looks like a V, Andy. Use your straight edge. Okay, so let's remind ourselves really quickly. Your H and K form for our absolute value function is always y or f of x equals a times an absolute value of x. X what? You guys continue. X what? Minus h, close up the absolute value. What else? Plus k. So in our equation, this is what you are given. Let's quickly state the a value. What's our a value? 2. What's our h value? Carefully, what's your h value? It's 1, okay? Remember, the minus h is already there, so the minus is already there. What's your k value? 3, okay? Now, a is positive, so that's only one transformation. Yesterday's notes, would you guys agree that a was a negative 3/4? So that creates how many transformations? 2. One's for the negative and one's for the 3/4, okay? So we're going to state the transformations. I have 3 transformation. I'm going to do 3 bullets right there. In your notes somewhere, I would like for you to state these verbally. Okay, you have plenty of space. Someone tell me the transformation for a that's bigger than 1. What does that say? When a is bigger than 1, bless you. A is bigger than 1. What type of transformation is that? Vertical stretch, very good. Vertical, make sure we know how to spell these out. Vertical stretch, factor of how much? Factor of 2, okay? Factor of 2. Then what's the h of positive 1? What does that do? Shifts to the right, okay? Shifts to the right. 1 unit. Now, it's k positive or negative? So what direction is that going? Up. Shifts up, vertically shifting up. However you would like to say that. Up, how many units? 3 units, okay? Now, I'm making a table for the parents right here. What is your parent equation again? Parent's equation is always what? Y equals absolute value. To get the 5 inputs and outputs very quickly. So x is here, y is here. What are the 5 inputs for the parent? Negative 2, negative 1, 0, 1 and 2. Should you be able to get the 5 outputs fairly quickly? Yeah, what are the 5 outputs? Yeah. So make a table for the parents, and then you're going to have a transform table, okay? These are the ones that we're going to use for plotting. Vertical stretch, factor over 2. Anytime you hear the word vertical, what is that changing? Changing the x values or y values? Y. What do we do with the 2 then? What do we do with the 2? Vertical stretch, yes, we're changing y. What do we do with the 2? Add, subtract, multiply, divide? We're going to take care of the 2 first. Vertical stretch factor of 2. What do we do with the 2? Multiply to what? The 2y. Shift to the right 1 unit. Is that a horizontal shift or a vertical shift? So that means we're changing what? X or y? X. What did we do to the x? Bless you. Add 1. You're right. Whatever x used to be, we're going to add 1. Up 3 units. Is that a vertical change or horizontal change? What do we do with that? Put it on the vertical. Yep. You're moving up, meaning you're changing y. You're vertically stretching or compressing. You also change anything that deals with vertical. You are going to change the y. All right, here we go. Negative 2. We used to have negative 2. We're now moving to the right by 1. What is it now? Negative 1. How about the next input? 0. Next? 1. Next? 2. And last. Perfect. Does that make sense that it did move to the 1? Okay, so we have to kind of match the verbal description of the transformation. How about the y's? Okay, we're going to take all these y's right here, and we're going to change it all right here. So we used to have a y at 2. 2 times 2 plus 3 is now what? 7. Next. 5. Next. 3. 5. And then? Are those okay? Very good. All right, let's plot. I have a -1. I need to go to +7. 2, 4, 6, 7. We have a 0, go up 5, 2, 4, 5. We have a 1, go up 3. We have a 2, back to 5. What shape is this, class? A V, okay. Make sure you guys make it look like a V. It shouldn't be looking like a U or anything else. Bless you. Okay, so now we fill out all of the characteristics. Let's sort of quickly look at the graph and verify if we did the right thing. Does it look like it got skinnier because we stretch it? Yeah. Did it move to the right 1 unit? Yes. Did the vertex look like it went up 3 units? So you sort of need to match your verbal description, okay? Kelsey, what's the vertex here, hon?
1, 3.
Good. Vertex is 1, 3. What is the axis of symmetry, Madison?
1.
Good, but what else do I need instead of just 1? X equals to +1. Beautiful. Does it look like it have any x-intercepts? No, it never, ever, ever cross or touches the x-axis. So you can say none or NA. Does it look like it have any y-intercept? Yes. What is the y-intercept? 0, 5. In this case, you can look at it and see, or you can look at the table and see that it is at totally 0, 5. Now, how come, what do you do then if you can't see it or you're not sure what it is? X-intercept mean the y has to equal to what? 0. And y-intercept mean x has to be 0. And you solve for it normally like yesterday. What is the domain for our v today? What's the domain? All real numbers. Would it be okay if we write -infinity to +infinity? Yep, either one will take. What's the range for our v today? What's the range? Amy?
Y is greater than or equal to 3.
Perfect. Anybody wrote this in an interval notation at all? Nobody? Okay. What do you guys write?
For -infinity.
It starts at 3. Does it go up or down? So that's towards what? What infinity is that if it goes upward? Positive. Yep. So would you guys agree? It starts at 3. It goes to positive infinity. At 3, bracket or parentheses? Bracket. It has to be bracket. On infinity, bracket or parentheses? Parentheses. Infinity, always parentheses. Increasing interval from where to where? Increasing interval from where to where? Remember, this is increasing right here when we have a positive slope. So where is that from? From, not 3, from 1, okay, to infinity. Remember, the axis of symmetry breaks off the increase and decrease in the absolute value function. How about decreasing function? This is a decreasing function right here. Where is that? -infinity all the way to 1. You're right. What is the rate of change? In this case, plus or minus what? 2. You're right. The slope is either a -2 or a +2. Is this function a 1-to-1 function? No. Okay. Do we have a minimum or maximum value? Which one do we have? Minimum. So maximum, you can write none or NA. I'll take either one. What is the minimum value? 3 at what location? At x equals to what? 1. Guys, that's pretty much like another way to say the vertex, except we need to, minimum or maximum is either the highest or the lowest. And the vertex happens to be the same in absolute value. Okay. All right, guys, guess what?